shut up. My name is Pau. I have been working on security information issues regarding Android. Formerly, I worked with Wi-Fi issues. And today I will explain to you a tool which is a script I made some years ago, and by commenting this issue with my friends at the bars, what is it? I always thought that it was a silliness, nonsense, but it seems that until you don't explain this to people, they don't know if they really know. People are surprised to know this feature, and that's why I'm telling you this story to you now. Let's see if I can launch the presentation with the slides. Fuck off, I can't see. The agenda for today, our agenda, the topic I will present is bypassing Wi-Fi paywalls with Android. I will tell you about how the hotspots work, the Wi-Fi capture portals work. Then we have to understand the vulnerability. Once we know how hotspots work, we need to understand their vulnerabilities and how to jump off the captive portal with a script, with a shell script, how to to transport the shell script to Android port for fun and non-profit, and then some attack mitigation recommendations and how to mitigate this attack. Let's move on to the next slide. Typical Wi-Fi paywall solutions are as follows regarding the captive portals. When we go to hotels, airports, cafeterias, we open our laptop and they ask us for registration to pay for access the internet. As when we put on some URL instead of Google or other websites, the captive portal appears on screen. But how do these portals work behind? Sorry for my skills, my bad skills at drawing this. This is the network schema. I don't have any short-sighted vision problems, but it's the way it is. As you can see now on screen, the cloud is internet. The gateway is, and then there is a switch to which two access points are connected, and then there is a client at the very end of the sequence. This is the typical infrastructure we can see on a typical hotspot. If there is a big hotspot, we can see several switches on cascading. Instead of 3 access points, we can see many access points, depending. There are as many rooms as there are on the floors, on the hotel. Distributed all around the facilities, and then an access points on every room. But the basis is like exposed there. Now, typical Wi-Fi focuses. Gateways replies to all ARP requests with its own MAC address used for client isolations to avoid communication between clients. Because when a client asks for the other's MAC's client or customer, the second client responses, and the router responses 3 to 4 times. So it fools the cache of the first client, and when you go to communicate with the other client, it's communicated through the router, not the other ways. Is it clear? If it's not clear, you can raise your hands, and I will tell you back. Apart from this, which is done only to avoid communication between customers or clients, we also do a redirection. We capture all the petitions, requests, HTTP, and we redirected them onto the hyper tablets to a local port where there is another server. It uses IP tables redirect to capture APTT traffic, sends to a 301 to an HTTPS web server, and then move on around. Then after redirection, the hotspot will appear on screen, will shot. How this work? We can see my skills in painting. We add them. There is, normally speaking, there is user databases, a web server. Perhaps everything is in the same machine, not separately. Normally speaking, this is not on the very same hotspot. Is on the cloud, is on the internet. To put it this way, what can we do? The user has to be authenticated. You can see this schema taken from the internet because I'm not a good painter. So client makes the initial request, the gateway sends 301 to redirect it to the web server, and web server gives back the form for authentication, and client enters the number of the user number and the password and gives another redirection after the form is posted to the gateway, and differentially speaking it sends a radius request against the authentication server. And there are two possibilities: of radius is accepted or is rejected. If it's accepted, it's marked as the client is authenticated on the internet. If it's rejected, it gets back to the previous website because your credentials are not valid. This is how this works. As you can see, it's very simple. It's this simple. There's no secrets in between. How can the gateway or the NAS know that the client is authenticated? Normally speaking, NAS know this through the IP address, the MAC address. There's some the parameter timeout when the client disconnects or is outside without doing any traffic. Automatically speaking, the connection is interrupted. When the customer comes back and starts another web session, instead of showing the login page or website, a cookie is stored where the credentials from the client are stored. And so when redirection is done, the cookie is requested and checked, and if this client is previously authenticated, you don't need to go through the previous login access website. Is this okay for you? So the important thing for me to highlight is, rather than the cookie, the pair of MAC address and IP address is the two essential elements for you to validate here. Now, networking, basic networking, everybody should understand that MAC addresses can be spooted, and IP addresses can also be spooted. Can be impostered. These IP and MAC addresses can be spooted through configuration. We need to find an authenticated host. That's essential. Sometimes, even you don't need to find an authenticated customer because you can do it with a bonus. Sometimes IP or switches can reach the internet. And when you do the loop going through all the IPs in the hotspot, you can't take other people's identity, and you can find the right exit. Some things about how abusing the weaknesses with a shell script. Look through all IP addresses. Through all the IP addresses, we need to get the MAC address for each IP. If MAC is using RPin or discard to detect with MAC, so we can use this IRPin, the RPin. You can get the 4 responses for the gateway and the 1 single response from the client. If we don't want the gateway responses, and we only retain the MAC address for us to use. And very simply, we configure our network interface with the target's host IP and MAC. We want to take their information from, and then finally we test for the internet access, for instance, with the pin 8888, and the moment we find the exit, we start the loop. That's it. Abusion weaknesses with the shell script. This is done in the time you can see on the screen. We can tweet you the URL later on, and finally the Android port is like that. It's only for fun and non-profits. It's for the sake of it. It's like going with the tablet or the phone on your own. It's an app launching and sending a terminal and a script. That's what you can see on screen. With a capture, with a snapshot from the screen, the script for Android is now on the market. I will show you a video for you to watch. 1 second, please.
Vale, esto es una tablet Nexus 7.
Nexus 7 tablet, where I'm asking for the rooted.s address. I was on a touch strolling around until I found a hotspot, .grill hotspot. I was sitting at the Burger King, and I spotted the rooted.s point and the login website's jams. Instead of authenticating, I used the application, which is a hotspot bypass, and automatically this the loop down, looping and looping and looping a bit more. Is looping all around the IPs until it finds an IP where it enables the Wi-Fi, changes to MAC, and enables Wi-Fi again, disables, enable, disables, consequently, and that's it. The connectivity is open, and now we are connected. We can see now that we are connected. As you can see, we got it. We got connectivity. We're changing some clients' identity who were connected at the moment. What can we do? What can Wi-Fi wireless provider do to avoid people doing so, to avoid these vulnerabilities? How can we avoid this kind of attacks? But it goes well is that the separation between users has to be done. Visibility between users has to be separated. If it's enabled, there won't be visibility layer 2 among clients. So we can use a VLANs per port. Perhaps there must be one client connected in one IP and another IP. If we have this done in such a way that the communication between the two clients is done through the switch port protected. Cisco has the switch port protected, so all the mouths from Cisco are seeing one single mouth, and we are avoiding visibility between clients, even though these clients are connected to different access points. The attack I previously shown, it won't work because we won't ever be able to know the MAC from the client. We can put the Wi-Fi on the same screen, we can capture traffic, and we can see the IP MAC because on hotspots, our Wi-Fi's are without any passwords. We see the IP and the MAC from any user connected at the moment, and we can take their data and access through them. For us to mitigate this, we can put on the switch port for security, which avoids that a MAC can be seen on different ports. This has some trouble. It doesn't allow a user to be moving around from different hotspots accesses, but it mitigates the previous failure. All major WISP in Spain, where I tested these issues, I've been using this for a long time now, all these major WISP points in Spain are vulnerable to this attack, only where the equipment belongs to them. For instance, airports, IANA electronic networks, R499 is not well set up. you can jump it up. But if you go on QB to a hotel, if it's their electronics, you can't jump of it. Telefonica and the rest of them, they have failures inside. I will show again my first drawing for you to check. That's it, period. If you have any questions, please raise your hands. Thank you.
Application
is on the market. If you check on hotspot bypass, you can access it. Anyway, I can tweet you all the information later on. Hello, thank you for your very interesting talk. A pair of questions, please. Do you have thought about serving for IPv6? I didn't find any hotspot with IP6 version. Second question. As you're talking about Android devices to change IP to Mac, you have the router ability enabled there. Yes, you're correct. In the script I done it, I devised it for two kinds of chips. Chipsets Qualcomm and otherwise. There are some devices on which this does not work. When you change the macro, you cannot associate with it. It depends on the device. I tested on Nexus 4. It works properly. Nexus 7 2013 works also properly, but for Nexus 5 doesn't work. When you change the Mac, is not associated with it. Some more questions, please. Raise your hands, please. That's it. Thank you.